Okay, so continuing with task number 2. As we talked in the previous video, we are right now at this stage. So what we have accomplished is the robot's supposed to move from point A to point B, and now it's the most interesting part, meaning moving from point B to point C. So we are at this stage, we are executing servo J. To do that, we set the input int register 0, which is our mode, to value of 2, and we send this value to the robot. Again, because the thread is running parallel to the main program, the value of the mode is going to be updated, and once it is 2, we are going to enter servo J part. In the Python code, we can see that we plan our trajectory for 8 seconds. The dt, which is our frequency, we want to operate the robot in 500 Hz. That's why it's 1/500. This is the time step. The plotter is a variable that allows me to control whether I want to plot the plots or no. And here, in the same manner as we talked in the first video, we implement our trajectory. You can look in the first video on this topic, and I explain exactly how this works. So later on, we implement state equal con.receive. This allows us to read the states of the robot. We read the TCP pose, and we run a while loop that's going to run from time equal to 0 to time equal our trajectory time, which is 8 seconds. Okay, so we want to execute our trajectory in 8 seconds. This is the main part. Over here, you can see that as long as the current time is smaller than the time in which we want to finish our trajectory, we are going to, based on the current time, obtain the reference position, linear velocity, and acceleration. And we are going to read the current pose and current velocity using those readings from the robot. And then the position, the pose in the Cartesian space that we want to follow is as follows. We want to take the reference position obtained from the minimum trajectory, but it is given as an numpy array, so we convert it to list. And then we want to have an orientation appended to it. Okay, so what we are going to get from the position reference, we are going to get x, y, and z, and the orientation constant is going to be ax, ay, az, which is constant and does not change with time, because we do not want to change the orientation. Once we obtain this pose, which is a list with 6 entries, we are going to change it to set point, and we are going to send it to the robot. So this all happens very, very quickly. I know that I explained it takes me a little bit of time, but this happens really, really quick with the robot, and you don't, as I said, it takes very, very quickly. So once we get to this point, the values of the input float registers are going to be updated to the new value that's based on our trajectory. We then can calculate the inverse kinematics that's going to give us a value of the joints, and those values of the joints are going to be updated over here. So we see here joints, we see joints over here, and this is how the values in the servo J are going to be updated at each time step from time 0 to our final time of the trajectory. So in this example it's 8 seconds, but it can be whatever time you want it to be. Those two values are velocity and acceleration, I believe. You can find more in the documentation, and for now they are not being supported to be changed. 0.002, this is the dt, this is the time step of our communication. 0.2 it's look ahead time. 2000 it's our gain of the PD controller. So we can see over here that we loop through the whole code, and we are going to basically keep looping till we reach the time of 8 seconds. And once this point is reached, we are going to exit this loop. Here I just print how much time it actually took, and then we are going to receive the state. We are also going to change the mode from 2 to 3, and we are going to send this mode to the robot. So again, in the thread we are going to read this mode, and once the mode is equal to 3, we are going to wait for a second and move J to the joins. What does that? This doesn't do basically anything. It's just going to stop the robot. I shouldn't have really this part, so let me actually delete it to avoid any confusion. So actually, once we have input int register 0 equal to 3, we enter mode equal to 3 and we stop the program. Then in the Python code, the connection, we stop sending any values to the registers and we disconnect the connection. Here I also have the plotter, so after the program has been executed, it plots our trajectory.